Welcome to the course on machine learning. So in today's class we will discuss introduction to machine learning. Okay, the contents are introduction to machine learning, what is well-defined learning and with examples. Then we will see issues and challenges and applications of machine learning. Okay, and types of machine learning, and finally we will see the introduction to designing a learning system. So what do you mean by machine learning? So basically machine learning is a subfield of AI, okay, that is mainly concerned with the ability of computers to learn from past experiences by providing some kind of data as an input, okay, that is without being explicitly programmed. So we want the machine to mimic just like a human, okay. So the term machine learning was first coined by Arthur Samuel in 1959. In the year 1977, Tom Mitchell gave the well-posed mathematical definition of machine learning. Okay, so we will see what is that well-posed mathematical definition of machine learning. Okay, in the next slide. So basically, the content, what we say, the components of machine learning algorithms, they are classified into three. That is the task to be done, and how we are performing the measure, that is P, and what kind of input, or we can say what kind of experience we are providing to the machine, that is our computer, that is called E. So what is well-posed learning problem that is defined by Tom Mitchell? So the definition given by Tom Mitchell for machine learning is a computer program is said to learn from experience E with some kind for some class of task T and perform measure P. Okay, if its performance on task T as measured by P improve with the experience. Okay, so we are given problem. Okay, so we try to find the solution to that problem. Okay, so we want the computer to get the more we can say accurate outcome. Okay, so we are basically measuring the performance, so by giving some kind of input, that is called experience. Okay, so we give input to the machine again and again, and the machine learn the input. It get experience from the input, from the training data. Okay, so at the end it gives us the output that we are measuring. Okay, so a well-posed learning system has three important key features: the class of tasks, okay, and what is the performance measure, and the source of experience E. Now let's see some kind of examples under a well-defined learning problem. So let's take this what we call as a checkers learning problem. So we have a checkers game. Okay, so let's see the three parameters for this checkers learning problem. So the task T will be we are playing the checkers game. So what is our task? To play the checkers game. So you can just imagine just kind of chess game. Okay, now the performance P for this problem is the percent of games won against opponent. So how many times we played and how many times we won the game. So that is our performance measure. So we want the maximum performance measure. And what kind of training input we are providing? So we are this what we say, we are the computer, the machine is practicing or playing the game itself again and again iteratively. So it gains experience. Okay, and so that it can come out with the this percentage of games won. Okay, so if you take another example, so we have this a handwriting recognition learning problem. So where we give the system some kind of handwritten digits, and the computer will tell us what is that digit. Okay, whether it is A, whether it is B, like this. So with the task, our task is we want the system to recognize and classify the handwritten words that includes images. Okay, now in the form of images. So what is the performance measure here? So we want how many words that are correctly classified by the system. Okay, so we want that performance measure as P. And what is the training experience? So we are providing the training data, has some database of some words. Okay, that are just to provide the input to the machine, so that machine can learn. Okay, so by applying some kind of algorithms, so it can recognize the characters, okay, the digits. Let's take one more example. So we have what we say a robot driving learning problem. So what is the task here? We want what we say, a robot to drive a car, for example, okay, in a some kind of highway, okay, by using some kind of vision sensors. So this is our main task. For this task, how we'll measure the performance? So up to what distance, without making any kind of errors, the robot has successfully traveled. So the average traveled distance traveled before an error, okay, that is our performance measure. So how much distance it travels, okay, the car travels. Now, so what is the training experience here? The training experience that we are providing to the robot, that is we are providing to the system, is some kind of sequence of images, so, and steering commands. So we provide some kind of images here. So if something comes, so move to left, if there is indicator, then move to right, like this. So we are providing some kind of sequence of images, so that the robot learn to drive, okay, in the highway. And so this is what is our three main features for this machine learning problem. Now coming back to the issues in machine learning, so let's see. So the first issue is what algorithms exist for learning general target functions from a specific training example. Okay, so what is this target function? So this we will discuss in detail when we will see this how to design the learning system. Okay, so here there are many algorithms that exist for building the target function. Means which function is our main what we say generalized function that the machine learning algorithm will use to for the understanding the input. Okay, so what algorithm exists for learning that, which algorithm is best for the target function. Okay, so that we will understand. That is the issue, okay, that we need to answer, okay, by giving some kind of specific training examples. Now what numbers of or what percentage of training examples we need to provide to the machine so that we want the accuracy to be improved. So how does this training example influence the accuracy of the this outcome? Okay, so that is our next issue. So sometimes we take the 75% of the training data as an input of the to the machine, or sometimes we take 70%, so it varies. So it depends upon problem to problem. So we want the more higher number of accuracy. Okay, so we can have this training example as an input. When and how can prior knowledge held by the learner, so here learner is nothing but the machine, guide the process of generalizing from examples. So what the machine is learning, or what kind of knowledge it is having before we are providing the what kind of some kind of input, so that it can generalize. Okay, so this is the general we can say function to solve this to have this input. Okay, so what and when how we can provide this kind of this knowledge to the system. So that is our issue in machine learning. And next is we have the target function and we want that function to be approximate. So we want that target function to be generalizable for multiple input types. So in future, if you provide some kind of random data to the system, so the system can that can classify okay, can give the output in more accurate form. Okay, so we want the function to be approximate enough. So this term we will discuss in detail when we will learn the designing the learning system. And next is the hypothesis we are building. What are set of hypotheses we are assuming or we are providing to the machine so that machine can do the task. So what is the complexity of the hypothesis that we are impacting to the machine system, and how does this affect? Okay, and how much training data is sufficient? Okay, that is the already discussed. So what kind of or what percentage of training data we need to provide, because we want the data we want some kind of testing data also, so that in later stage we can test the machine whether the machine is performing well or not, or whether we need to provide more kind of training data. Now the next issue is what is the best strategy for choosing a useful next training experience, and how does the choice of this strategy alter the complexity of the learning problem? So basically what is our best approach? Okay, so what kind of training experience we are providing to the machine, and how does it choose the strategy, so that the what we say so complexity is reduced and we get the higher accuracy. Okay, and what is the best way to reduce the learning tasks to one or more function approximation problems, and what specific functions should the system attempt to learn. Okay, so this is nothing but we are trying to build a model. We are trying to build a machine learning problem, solve this problem, so that the function that we are coming up, that is the target function we are coming, and how we are representing the target function and how we are approximating that function, so that we can arrive to the final design, okay, by choosing some kind of algorithms. Okay, that algorithm can be our supervised kind of or unsupervised kind of algorithms. Okay, and this is what we are and how we are training the machine. So this is all about this issues. And how can the learner automatically alter its representation to improve its ability to represent and learn the target function? Yes. So how machine is iteratively learning from its own experience, and how it is what we say representing the target function and generalizing the target function. So in step by step, how it is varying the weights, or we can say varying some kind of values, and coming up with a final what we say target function. Okay, so this is how it is self realizing the this learning problem. Okay, now so machine learning provides a vast applications. Okay, so we will see what are different applications of machine learning. So in the field of medicines, in the field of computer vision, we can apply machine learning algorithms. Traffic prediction, so what kind of traffic is there in some kind of areas. Okay, the traffic we can predict. NLP, natural language processing, is also one kind of application. Finance, then we have how to detect this online fraud, that's credit card or debit card fraud we can say, and how to understand the consumer sentiment based on some kind of unstructured text data, so that is called a sentiment analysis. Okay, so this is also one application of machine learning. Now coming back to more applications, we have classification, classifying some kind of data, whether it is class A or whether it is class B, predicting some kind of feature values, predicting the forecast of the weather forecast. So this kind of prediction we can do. Okay, regression. We have linear association, image and speech recognition. Okay, and virtual personal assistant. And we have product recommendation, and finally stock market trading analysis. So there are plenty of applications of machine learning, okay, to work on. Now so moving to the next, the types of machine learning, what we'll say we have. So broadly we have three classes of machine learning: supervised, unsupervised, and reinforcement learning. So what do you mean by supervised learning? Basically, so supervised learning means we have a label data. We are providing the system a label data, and based on that label data, our computer try to we have recognized the target function, and we get the what we say mapping. The algorithm try to learn the mapping function from the input to the output. So we are providing input as a variable, and we are getting output as a variable. Okay, so that is called as a supervised learning. So okay, now so supervised learning means develop predictive model based on both input as well as output. Okay, so we have clustering examples of supervised learning, clustering, regression, we have linear regression, we have logistic regression, we have decision trees, random forest, okay, KNN, naive Bayes classifier, support vector machine, like this. So these are the supervised learning algorithms. And next we have unsupervised learning, means there is no label data. Okay, just we have seen in the supervised. So without being there is no proper explanation of the data. So here it is nothing but how the machine is able to do that what we can say categorization of analysis based on the data that is unlabeled. Okay, that is called as clustering. So that is what we see in the unsupervised learning. Okay, so based on the input data only, and is try to predict the what will be the output. That is called a clustering. And lastly we have reinforcement learning, where we provide the machine some kind of past experiences, past knowledge, and the machine is able to recognize the what we can say understand the this input, and just try to answer the output. Okay, so this is all that is machine is able to take decision its own. It is recursively or iteratively learning itself. Okay, so this is called as reinforcement learning. So these are the broad various what means algorithms under this supervised and unsupervised learning. So we will discuss each and every these algorithms in detail in coming lectures. Okay, now so this is I will left for this next class. So this is what we say designing a learning system. So this is very, very important. So it is a learning system designing principles. These are the 5 steps. So this we will discuss these steps in detail in our next lecture. Okay, so thank you so much.